Hi, this is going to be lab number 7, Logic Design with K-mapping.
Alright, so lab number 7, what we're going to be doing is designing some logic. So in this particular case, the logic we're doing is for a 4-bit binary number, which is guaranteed to be in the range 2 to 13, so we don't have 0, 1, 14, or 15. We need to output a 1 if and only if the input number is prime. And we've already gone and analyzed this in the other video, done our K-mapping technique, and then implemented a sum of products, which we've then converted to a NAND implementation, and even drawn out in multisim. So now we just need to implement this in the lab. We've got our 74HC00 quad 2 input NAND gate chips again, and based on the design we're going to need 8 different NAND gates, so we'll need 2 of these chips. So we can go ahead and put those into the breadboard, putting the little indicator, the little divot, facing left, just to keep things straight on which way is pointing which way. And now, to remember which one is which, we can sort of go around kind of like 1, 2, 3, 4 around the chip, and then just label them over here to decide which gate should be where. So let's see, considering what needs to be connected to what, it's probably simpler if we have everything generally going from left to right across this chip. So maybe we can put this one as number 4, just up at the top, and then that needs to feed into this one. So maybe we'll do that as number 4. We can put this one as number 1, and that also needs to go into an output of this. We can put that as a 2, and then maybe we'll put this as a 3 down there. We'll see how this works out. And then over here, for the chip number 2, so this will be maybe the first one, and then B can be over here, where we'll do, so we were doing 4 and 1, we can jump that up to this one maybe, so that'll be 4, and then number 1 on the other chip can be jumped to next, maybe we'll do 1 like that. Then we can do up on the top, let's say 3 and 2 will be the output over there. Okay, so that's going to be the implementation of the entire gate network. Now we need some input wires, and I think what we'll do, given that we don't have 4 of the same color, maybe we'll trade with the person next to us so that we can be consistent. So rather than, you might think, okay, we have 3 greens, we have 3 blues, we could sort of split it up and make the input green and blue, but maybe an easier way to see would be to go to the partner and say, hey, I'll trade you this green for this blue one over there. Thanks, partner. And now we've got 4 different good blue wires that we can use for the input. So let's start off by wiring each of those ones to low, up there. And we'll just imagine that left to right, these are A, B, C, D. To make it easier to move, actually I guess that's possible to move like that even when they're all together. So that's alright. That's going to be our A, B, C, D up there, or I guess as we've called them, ASDF. Now we can check which of the gates these connect to. So A needs to connect to the input of gate number 4. There's our A there. And that's going to go to the input of gate 4, which is number 13 there. We're going to take S to the input of gate number 1, which is down there. We're going to take D going to the input of gate number 3, which is up there. So that's pin number 9 and 10 on this one. So either of those would be fine. And we're going to take F to two different spots. So F connects to the input of gate number 3 and the input of gate number 2. Actually, S connects to the input of gate 1 and to the input of gate 2 as well. So the way to do this is, rather than having a different one for the input, we'll just have a jumper wire after we've connected it to go to the other spot. So we'll take here F to the input of gate number, what would be closer? Let's say the input of gate number 3, so the other input of gate 3, and that would be this one right here, beside where D is. Then we'll have a jumper wire to connect that over to the other spot that we need. Now, for the jumper wires, rather than using these wires, what we can do to make things a little bit cleaner, especially for the little connections that are just bridging the two inputs of the gates, is to get some experience using wire strippers and making little wires here. So we take the box of wires, which is available up at the front of the room probably, and then from within this box of wires we grab the wire cutters, and we're going to need to make a little tiny bit of a wire to bridge two different spots. So the first step in that is to cut off a little bit of the wire. So let's say something like that. And now, with this little bit that we've got, we need to take the shield off of it, so we need to strip that off of the wire. And for that, it's hard to remember which spot you put it in of these different spots. So basically you can try one that's too big and see if it grips, and it doesn't. Then go a little bit smaller, doesn't quite work. So let's try that one, not quite. Looks like we're going to use the smallest one. And clamp and basically work that off of there if it's working. So this one seems like the wire strippers are not quite closing to the right amount to get this to actually work. Okay, well, we'll see if we can find some better wire strippers. So if that happens, if you find like it's not actually reaching and cutting through the shield for the wire strippers that you have and the wire that you have, then the best bet is to just go and get a different set of wire strippers. So this one here is more flexible in a way, but it's a little bit trickier to use. Basically, you can clamp all the way down to almost nothing. So this will work for a really small wire, but it also relies on you to sort of go by a little bit of feeling on when you've got it to the right level. So with a bit of sort of clamping and twisting there, you can work the shield off. If we get that to work. Okay, so there we go. Got that off of there, and then we can bend this around to be a little tiny bridge connection that's going to bridge two adjacent spots on the breadboard. So for instance, spot number 4 up there, we need to connect both the inputs together. So what we'll do is go and get this fitting into both of those two spots. There. And so, as you can see, it's a lot more work to get that to work than just using a jumper wire, but when it's all done, it is a lot more readable on the circuit at the same time. So we'll need to basically repeat that step for different spots on the breadboard there. So we'll get that piece, we'll cut that one. Not the greatest wire cutters, but we can still make it work. And strip off that plastic. There we go. Now we'll bend this to get two pieces that are close together, and then go and place this in another spot that's jumped. So for spot number 1, we need both of those inputs to be connected together, which are right on the very left of this board there. Great. So that is in both sides, so we're good to go for that. We've got this one in there, and you can see it is kind of a pain to go and make these little tiny wires for the breadboard, but it does make it a lot neater. So for something like the design project where you have a lot of wires flowing around, as much as it's a bit difficult to make these little jumpers, it's probably essential to be able to read what you've actually done. So the next thing that we're going to be doing is creating all of the intermediate wires to jump this this logic across. So now let's create. Let's use yellows maybe for jumping these inputs to different spots. So we need F, which is this 4th one, to not just go to the input to 3, but to also be connected to the input of 2. So that's going to be from there. So we'll go on the input F spot over there to the input of 2, which is number 5, let's say. So that's 7, 6, 5, and then we'll do the same thing for S, which is connected to the other input of 2. So S, which was connected down here to number 1, is also going to be connected over to the input of 2. So we'll use that for the other input of 2. And that's going to be up there. Okay, great. So those are all the ones going from the first stage to the inputs. Now we can go for the outputs from that first row over to the other board here. And maybe for that one, we can pick some different colors. So we've got these greens as intermediates to use for that. So we'll take, how about we go green for these 2 wires that are going to that, that spot on 4. So we need the output from 1 and the output from 4. So the output from 1 is down here on pin number 3. So we'll take that one and we'll bring that over to the input of number, the input 4 of this second one there. So that's pin number 13. Then we'll take the other one is the output of 1. Well, that's the one we just did. We need the output of 4, which is up here. That's on pin number 11, and we'll bring that over to the other input there. Okay, so now we've got 4 all wired up. Next thing we're going to need is the output of 2. And what can we use for that? I've already used some yellows. Let's use gray. Okay, so output of 2 going over to 1. And 2 was this one down here. The output is on pin number 6. And we'll put that over to 1 on the second chip. So that's this one there on that input. And then the other one that's going into pin number 1 is 4. So rather, not pin number 1, going into this gate 1 on the second chip. So we'll take the output of 4, which is up there on pin 11, and we'll bring that over to pin number 2. Great. Next up, those ones go over to 3, which is the other one we've put this this jumper to convert it into a NOT gate. So maybe we'll use purple for that. Pin 3 over to gate 3's input there. Next up, we need to wire gate number 3's output over to the final gate's input, which is gate number 2 there. So what are we left with? We've got this sort of whitish one with a black stripe. So maybe we'll use that for this last one here. So gate 3 has an output on pin number 8 up there, and we'll put that to one of the inputs here on for number 2. should be 4. And the other one that goes into that is the output of number 3 on the second chip, which is pin number 8 there. So that goes over to that input, and this one right there, 6, is going to be our final output. So we're going to jump from that with this 1K resistor. You have to use the right resistance. If you don't use a 1K, if you use a smaller resistor, then your LED is going to be really bright because you're running too much current through it. It's going to mess up the logic of the rest of your circuit. And if you use too high of a resistance, then the LED is not going to go on. So we'll go from there into the ground. Okay. And next thing we're going to do is wire up the circuits. So this should be completely done. Let's check that every port on both of these gates are wired up to something, and they are, except for the VCC and the ground. So we left those ones for last, and indeed everything else is wired and those ones are not wired. So that's great. So now we'll take a black plug for the grounds, and we'll go from that pin to the bottom rail ground, and same thing with that one, making sure that we haven't plugged into the wrong spot there. Now we'll take some red ones for the highs. We'll go from pin number 1 over to a high, and I think I'm going to use the bottom one just to keep it away from our inputs there. And on this one, we've got lots of space, so we can use the top rail. Okay, now we need to wire up the top and bottom rails together. So we've got red to red. And do we have another black wire? Yes, it's a little bit mangled, but we can see if it'll still work out for us. Black over to black. Okay. So high to high, low to low, very easy to see what's going on because of the color scheme that we're doing. And everything should be wired up now, so we should be in a good position to power up the whole thing and see if it works. So we've checked already that the circuit is set to 6 volts and has a reasonable current limit. So we'll wire up the lows and the high. Okay, now we'll put this to a logic that should give us a prime. So if we were to connect pin number D here to high, then the output pin should go high if we haven't wired anything up wrong. And then very unfortunately, it has not. So alas, this means something is miswired on our circuit. So now we start the fun part, which is the debugging of everything. So what I would check first is the current that we're putting out. So we're putting out pretty much 0 current, and that makes you wonder whether or not we have power into the circuit at all. So do we have kind of a funny connection there? Are these both connected in on our rails there at the top? Is everything connected grounds and VCCs of each of the logic chips? There we go. Okay. Oops. So something is sort of a funny connection somewhere. It came on for a second. Ah! Our LED missed and inserted into the wrong spot. So there we go. Okay, so the LED is now connected, and let's check. 2 is prime, 3 is prime. However, 6 and 8 are not prime. So let's check. If we were to switch it over to 10 here, it should go off. Yes, great. But if we go to 11, it goes on. Okay. And what else do we need? 9 should go to, so this is 3, that's prime. And if we go to 9, that should go off. Wait, that's 7 actually. 7. So if we wanted to go to 9, we would plug that into there. So that's 1, 0, 0, 1, and that's off. Okay, great. So it looks like it's worked. We are verifying that this is a detector for whether our number is prime. So another verification thing that we could use is right now when the LED is on, you notice according to this box, we're drawing a really small amount of current. I'm not sure if I actually believe this. So this says that we're only drawing 1 milliamp, and that's probably not enough to make this on as bright as it is. Still, if we disconnect the LED completely, it drops down to 0. I'm not sure I believe that either. But one thing you can do to check is switch around the inputs. So in particular, when we have an output that's supposed to be low, we'll put the LED back in to show that this is a low output as opposed to this high one. Interestingly, this particular circuit is drawing a different amount of current, in fact a lot more current, 18 milliamps according to the power supply, when we are outputting a low. And that's the same across a couple of different lows. So here's 8, and then we'll put it back, we'll go to 9. Whereas if we go up to 1, it goes back down. So another thing that we could have done while debugging, if we hadn't seen that light go on for a moment, to check if things were actually hooked up across the boards here, is mess around with the inputs and see if that's giving us a different result on the current. Other tricks that we could do if things still weren't working after we checked all the wires would be to hook up the multimeter and double check that voltages in different spots are what we think they should be. And that's basically what you do.
So that's it. Thanks for watching. I'll see you next time.